Page 2, here are the notes for 13.7 about inverse trig functions. So the cool thing about this lesson is we've actually already been using these, we just haven't been calling them by their real name, or maybe you have and just didn't realize it. So sometimes the value of the trig function, those fractions we've been working with, is known and it's necessary to find the angle. So we've been going angle to ratio, now we're going backwards. So given sine of x equals 1/2, what is the value of x? Well, the cool thing with this is what we've been doing in our calculator. So we go second sine 1/2, and then our calculator gives it to us in degrees. So for this first problem, all I have to do is say that sine to the -1 of 1/2 is equal to x. This is called the arcsine function. So in your calculator, these little yellow spots above are called arcsines. And if I throw that in my calculator, we just saw that it was 30 degrees. Now you can look at this table a little bit, but essentially all that this says is these are different ways to write the exact same idea. So find each missing value and round to the nearest tenth. Well, if I know that my cosine ratio is 0.4, then I can just throw it in my calculator as inverse cosine of 0.4, and my calculator will give it to me in degrees. So in this case, my x is going to be 66.4 degrees. If I keep going, I can continue to just plug these in the calculator as second sine 0.15, and this one is going to be x equals 8.6 degrees. Again, it says round to the nearest tenth. Make sure you're reading directions so that rounding doesn't get you points taken off. The same way I can do it with cosine and sine, I can also do it with tangent. Second tangent of 1.7 will end up giving me a degree measure of 59.5 degrees. It works with -2. When I throw that in the calculator, I'm not going to show you how to throw it in because you can do that, but it's 103.3 degrees. So in reality, there's a lot more than one solution that works, and we are just finding the easiest one. Now there's additionally another way to do this. Sometimes you'll have nice values. You'll have something like arcsine of √3/2. Now, while we could just throw this in our calculator, we can also use radian-man to find it. So if I look for this in my sine value, so I'm going to go through here until I find it in sine. I find √3/2 in the sine position, and then I look for its corresponding degree measure as well as the radian measure. So because I can go from 60 to this value, I can also go from this value back to 60. So if I'm looking for each value in degrees and radians, this one would be 60 degrees or pi/3 radians. Tangent is a little harder. I just suggest throwing that one, unless you know the tangents and you have them memorized. Otherwise, I would just do arctan of √3/3, throw it in a calculator and get 30 degrees, which we also know in radians is pi/6. And we can keep going with this. I'll let you find those last two. I would pause the video, see if you can get those in your calculator on your own, and then unpause when you're ready. All right, hopefully you paused the video. If you did and you found these, you'll see that that one's 120 or 2 pi/3. This one is going to be 270 or 3 pi/2. Now sometimes we have trig functions inside of trig functions. So these ones we can't just throw into our calculator, we actually have to draw a triangle. So I'm going to put in my parentheses here, draw the triangle. And just like we usually do with our parentheses, we want to work inside out. So if I know arcsine is 5/13, I'm going to draw a triangle and I'm going to find the information that I'm capable of. That means that sine is going to be 5/13. Use Pythagorean theorem to get that last value. You get that it's 12. Once I've set up the triangle using this inside information, this is what I'm going to be looking for. So what is cosine of that theta angle that I set up? Well, cosine is adjacent over hypotenuse, so in this case, it's just 12 over 13. So what's inside the parentheses helps you draw the triangle. What's outside of the parentheses is what you're looking for. Let's see that again. Cosine, arc cosine actually, is 2 over 3. So when I set up my triangle, that's the same thing as saying this angle is equal to cosine, where it's 2 over 3. Use that Pythagorean theorem again, you get the third side. And once I've set up the triangle, I'm looking for tangent. Tangent of theta is opposite over adjacent, and my final answer is just root 5 over 2. All right, last problem. So, each leaf of a certain double leaf drawbridge is 130 feet long. If a 80-foot wide ship needs to pass through that bridge, what is the minimum angle to the nearest degree which each leaf of the bridge should open so that it'll fit? Well, I immediately looked at this and I realized if this comes down equally and half of the boat is going to take up that space, it means there's 40 feet there that are going to be cut off by this bridge. So I know that I can find this little area by just saying 130 minus 80 130 minus 40 to give me 90 feet. Once I know how much of that bridge is left there that the boat would essentially miss if it went directly through the middle, I know that this triangle then has a cosine value, cosine theta, of 90 over 130. After I know that, I can just do the arc cosine. I can say cosine of 90 over 130 equals theta. When I plug that in, I get approximately 46.1, maybe 81, I think. But when I round it out, I think this is supposed to be 7 or something like that. When I round it out, though, to the nearest degree, I get that this is 47. So with this boat specifically, I have to find this value first, or I only have one side of my triangle, which is not enough to determine the overall problem. All right, let me know if you have any questions.